So, today I will discuss about another basic apparatus. So, that is cathode ray oscilloscope CRO. So, all of you are quite familiar with this apparatus, and this is a very useful apparatus for the laboratory. So, uh, CRO is I have taken picture of one of our CRO in our lab. So, if you see the front panel of this CRO, so here you can see there are different parts, there are many knobs and one skin is there, right, one skin is there, and then there are knobs here, this is the one set of knobs. Okay. This is there is a demarcation. Okay. So, this is another set of knobs. Okay. And this lower part, this is again demarcated, you see. So, this is another set of knobs, and this fourth set of knobs is this is also demarcated, right. So, if you see the front panel of this CRO, front panels of the CRO. So, I can tell this is front panel is basically arranged in a in 4 blocks. So, this I mark with red color. So, this is a display, and display control. These knobs are basically to control the display on the screen, whatever we will display on the screen. So, that will be controlled by this 4 knob. So, I will tell what are those things, and then second one is basically vertical controls, still vertical controls. So, this one is this lower one, these blocks. Okay. This violet color, this box. So, this is basically is for vertical controls of the display, and this part is basically horizontal control of the display, and this fourth block here. So, it's basically trigger or sweep control of the display. So, basically what is the use of this? Let us see first what is the use of this CRO, what we do with this CRO. So, CRO is a basic instrument to study the different types of waveforms. Okay. And it is used to measure DC and AC voltage, frequency of the waveforms, phase difference, pulse width of waves, then delay time, rise time, fall time of the waveform, okay, of the waves. So, that is the things one can do, means we can display the wave forms on the screen, and then from there we have different control to change the to basically to manipulate along the x direction, along the y direction, and also time. Okay. We can manipulate, and which helps to measure these parameters whatever I told you. Okay. So, basically if I give input to the CRO, so I have here this, I have taken pictures of this CRO right here. If you see, so this is a, I think I should put this way, then so This is the CRO. I have taken picture of this one. I think it will be difficult for you to see. So, this is the screen, okay, display screen, and then bottom of this one is basically the display control, right, and this lower that block, lower block. Okay. So, I think this is the lower block, okay, this part, these two and other. So, this part is basically I think this the vertical control, okay, along the y axis vertical control, and this part is the horizontal control, means along the x axis horizontal control, and this part is basically for triggering or sweeping of the waveform. Okay. So, this the we tell triggering or sweep control for this oscilloscope. Okay. So, I will show you parts by parts. Now, if I this here basically is a 2, you are seeing this here is written channel 1 and channel 2 is the vertical control. Basically, we apply signal in vertical axis, means along the y axis. So, this signal we connect here. So, through BNC connectors, okay, some signal connectors, we give the signal here. So, basically 2 channels are there, means 2 signal we can put, and there are here also we can compare with these 2 signals at a time. So, one signal you can use and you can measure the frequency, etc., voltage, right. So, you can analyze the one signal, one waveform, okay. Or if you want to compare, or if you want to multiply or superimpose these 2 and this, like Lissaj's figure, we can study the Lissaj's figure using oscilloscope. So, now if you want to study the 2 waveform and their superposition, etc., so then you can give 2 signal in channel 1 and channel 2. Okay. So, 2 channels are here, okay, and here if you see here, whether you can see or not, I will show in picture. This is volts per division, these are written volt per division. Here also the same thing, volt per division for channel 1 and channel 2, and here it is written time per division, okay. So, this horizontal control, this part is horizontal control, this part is vertical control. Okay. What is control? What we are going to control? Okay. So, if we put some signal here, it is displayed. If it is sinusoidal waveform, so it will come on the screen, sinusoidal waveform, it will come on the screen. Okay. So, and then I am just rotating the knob, reading the following the manual, just I am rotating the knob and measuring the things. Okay. But when I am rotating the knob, actually what is happening? What is inside in this CRO? So, just when I am rotating, so inside what is getting changed, so that my display is affected. Okay. Display is getting changed. Okay. So, that is what I would like to tell you, that when in front panel there are many knobs and it has different function, and now we will be able to use this function just reading the manual of this oscilloscope without knowing when I am rotating the knob what is happening inside, what is there in inside. So, what is the connection with this knob, with the with knob and this inside component. So, that is what I would like to tell you, I would like to show you. So, let us open this this box. So, I will open this box. just I think I have to just open. So, it was in cover. So, I have opened it. So, this just only cover. So, let me take it out. Now, I think I will. So, this is the front panel. Okay, I have shown you this is the front panel. So, now I have opened it. When I opened it, I can see this half of the portion of this inside of this one is one tube. Okay. So, this tube is called the CRT, cathode ray tube, and it is basically, you see, it is basically with display. Okay. This tube end is basically the display, and this other end of the tube, you see, other end of the tube is just with its this is the back side panel. So, here you see this is the power, with power cord we give power 220 volt, and here something whether you are using 110 volt or 220 volts. So, depending on that there is an option to choose. So, in different country there are different line voltage. So, in our country it is 220 volts. So, that option is there. So, accordingly one has to put. So, this is the basically jacket. Okay. This is the jacket, and here if we have 220 volt. So, then you can use this here AB and CD, these two marking are there. Okay. So, for CD it is 220 volt, and for AB it is for there is some range 90 to 110 volt, okay, 125 volt, and here 194 to 250 volt. Okay. So, in our country it is around 220 to 30 volt. So, CD, so that range is suitable. So, I think I just yes, yeah. So, one has to put accordingly. So, here we have put as per direction. So, it is the this I have put. So, it's I have selected 220 volt. Okay. So, this is the power using power cord. So, we give our line power here. So, this line power, if you see the inside, yes, if you see the inside, okay, this power part, this is the power, here I have given power. Now, inside if you see inside this power, here this power socket, here this power socket, here this power socket, and this power here inside this. So, this is going here. Okay. Now, from here one part is going to this side, another part is going to this I think where is CRO, this other side, CRO is other side here. So, I have to see this power here. You see there is a board is connected to the CRT, connected to the CRT cathode ray tube. Okay. So, this power, this is coming from this basically from here it is, yeah. So, it is basically coming from here. So, power from here to all board it is going. So, this one is transformer. Now, in this for running for operating this CRO, we need very high voltage for CRT cathode ray tube. Okay. And for other component, this other control, horizontal control, vertical control, triggering. So, you need normal power. So, here basically our normal line power, and from line power to its one part its going to the transformer, and that from that transformer this power we are giving to CRT cathode ray tube, because therein we need very high voltage, it is in kilovolt range volt. Okay. So, it is going to CR2, okay. And this other part is going to the other electronics, which is used for controlling the x axis y axis display and triggering of the display on the screen. Okay. So, these are the more or less. So, here what I want to tell you, this main part of this CRO is CRT, cathode ray tube, right. It is display, and there are other things, all are electronics for this other three control. For one is for vertical control, another horizontal control, and fourth one is this triggering or sweep control. Okay. So, this so that is the function of other electronics, lot of things are there, but main part is CRT. Okay. So, this is the inside of the oscilloscope. So, so now as I told that CRT is the main part of the CRO. CRT is the heart of the CRO. CRT means cathode ray tube. Okay. So, let us learn it first. Cathode ray tube, what is cathode ray tube? Now, in CRO we can display the in CRO we can display the signal waveform, say whatever, if it is sinusoidal waveform. Okay. So, this is the x axis and this is the y axis. Okay. So, what is waveform? So, just we get this kind of right. So, if this is the signal, I want to measure the signal, it has one is frequency, means x axis will be time scale and y axis will be voltage scale. Okay. Y axis, this is x axis and this is y axis. Okay. Okay. So, and it is on the screen, it is grid type of this there. Okay. Scaling are there. Okay. Each one is 1 centimeter and in between 10 divisions are there. So, and there is a calibration, okay, time per division and volt per division, as I showed you, that is written volt per division, time per division. So, this for horizontal case it is a time per division. Okay. For vertical case y axis, this is the time per volt per division. So, so that calibration is there, or one has to calibrate. Discalibrate, we can also recalibrate also. So, this is my signal. Okay. When I will put in this signal to the CRO through the channel 1, say, then on the screen just exactly I will see this type of picture, this type of image, as if someone is plotting. So, someone is plotting this variation on the CRO screen. Okay. So, now who is plotting that one, how it is plotted, how we are seeing. So, basically we just see of the CRO this just light, right, sweeping of light or variation of light along the x and y axis, right. So, now how it is happening when I am giving this signal to the channel 1. Now, on the screen this kind of things is displayed, Okay. So, how it is happening, that if we want to know, then we have to know the function of CRT. We have to know the function of CRT, right, cathode ray tube. So, now for basic things, you know, this if you take just whatever we know so far, okay, from basic physics, you know, this if you take a filament, right. So, in our home, this bulb, we are using bulb, okay, 50, 60 watt bulb, 100 watt bulb, and there inside bulb we have seen there is a filament. Now, when this filament glows and we get light, right. Actually, filaments, when it is heated, so that means some current you have to pass to this filament, okay, low current. So, then it will glow and it will emit electron. So, this filament will emit electron, and that in front of it generally we put some cathode, we tell cathode, some cathode material. Okay. So, it is the with lower work function. So, this electron emitted from this filament, it will hit this cathode. Cathode is of lower function, this its work function is low. So, from the surface of the cathode, lot of electron will come out, right. So, basically it's you can tell this a thermal emission kind of things. Okay. So, lot of electrons will come out. Now, if I apply very high voltage between a screen and the cathode. So, this screen we tell this is a anode, it is a anode. Okay. So, if we apply very high voltage between this cathode and anode, then there is a huge potential difference between cathode and anode. So, now this electron will be accelerated and move towards the anode, right. Why? Because it will these electrons, you know, this Lorentz force due to electric field. So, that force is Q into electric field, So, here we have applied voltage. So, electric field will be generated along this direction, and this electric field is a voltage by this distance. Okay. So, that will be the electric field. So, due to this electric field, so this charge will get force, okay, and due to this force this charge will be accelerated, and these electrons will come and hit this anode. Now, this anode surface is coated with some phosphor material. If it is coated with some phosphor material or fluorescent material, then when electron will hit this screen, this anode is basically, in this case, if it is screen and that screen is coated with the phosphor or fluorescent material. So, when electron will hit this screen, then wherever it will hit, so it will be illuminated. So, we will see light there. So, basically on the screen whatever we are seeing the light, that is nothing but the position of the electron, okay, position of the electron. So, basically these electrons from the cathode, it is accelerated and hitting the screen. So, basically due to, so you will get a beam of electron, you will get a beam of electron, you will get a beam of electron on this, so it will hit the screen. Okay. Now, so what you will see? You will see basically a spot on the, you will see a spot on the screen. Okay. So, there is a light spot, that is basically the electron spot of the electron beam. Okay. So, now this spot on the screen, and now you want to manipulate the spot on the screen. Okay. You want to take on off, or means along the x axis. If you want to take this this towards left or towards right along the x axis. Okay. So, if I take, this is y axis and this is x axis. Okay. So, if you want to take spot x axis, y axis, okay, how I can do that? Okay. So, or the spot is not at centered. Okay. It is not exactly at center. I have to bring the spot at the center. Okay. It is off centered. So, I have to bring the spot. So, to manipulate the position of the beam along the x axis or along the y axis, or in any direction. Okay. So, I need basically some arrangement. Okay. So, that is basically whatever this I told this vertical control and horizontal control. So, to manipulate this beam spot of this spot on the screen, so we use these two, we need these to control horizontal control and vertical. What is that? It is nothing but, you know, this I have shown you, as that is what I told you, this if I apply electric field, you know this, if I, so if I have a two parallel plate. Okay. If I have a two parallel plate, now if I apply voltage in this two parallel plate, so then I will get electric field. Okay. I will get electric field along this direction. Right. Now, if charged particle comes, if charged particle enters into this, okay, this, so it will feel, it will get force due to this electric field along this direction. So, that is E E, okay, Q E or E E. Okay. So, due to this force, it will move along the electric field direction, right. So, if I arrange here along the y axis, if I arrange here, I think, yeah, if I arrange here two plate, two metal plate, okay, and apply voltage, so it will give electric field along this direction. Okay. Now, this charge particle, this charge whatever beam, electron beam is going, so it will get another force along the y axis, So, this electron beam will not go straight, but it will bend. Okay. So, this way you can change the position of the electron beam up and down. Okay. So, this one has to choose the polarity. So, if you want to take down, if this is the 0 position, okay. So, then for going up and down, one has to take polarity, change of polarity. So, this along the y axis, similarly you have to put two plate, So, basically here the way, so this is x axis and this then it will be y axis. So, I have to one plate in bottom and one plate is up. Okay. So, this will give you this another electric field. So, two sets of, so this is the for y plate and another set is x plate. So, this x plate, so voltage will be applied. So, due to electric field along the x direction, and if I take, this is the anyway. So, I think here I could draw in different way, x axis, not this on x axis, this I could take as a z axis and x axis may be this way, okay. X axis may be this way anyway. So, this will give you this electric field in along the x direction, this is giving the electric field in along the y direction. Okay. So, two sets of plates along the x axis and along the y axis. So, this is used. So, this arrangement is there in the CRT tube, okay, to manipulate the beam spot on the screen along the x axis. So, this x control, vertical control, y control, this vertical control, and x control means horizontal control. So, these two parts in front panel I showed you, there are two parts, two blocks are there, okay. And yes, now this whole thing. So, so this arrangement is there. Now, this whole things is put in a basically in a vacuum tube, and this power it is given through the pin, okay. It's called feed through, okay. So, through feed through we give power to this, to inside whatever, to the plate, capacitor plate, and filament and the power between the voltage between the cathode and anode, okay. So, all power is going through this feed through, and so all things are. So, why we need vacuum, why not is in here? Because if it is here, so what will happen is this there will be collision with the air molecules, and then before reaching to the skin, it will be deflected in different directions, and also it will glow, because it may be due to collision with this air molecules. So, it will glow inside itself, okay, before reaching this. So, this tube will glow basically, okay, if it is filled with air. So, we need vacuum, just we want this electron emitted from the filament or cathode, it should reach without deviation, it should reach on the screen, okay. So, this CRT tube is a cathode ray tube, this cathode ray. So, this electron beam, it is called basically cathode ray, okay. So, because it is coming from the cathode, so that is why it tell cathode ray, and this ray basically CRT tube produce the ray of electrons, okay, beam of electrons, and it hits the anode, it hits the screen coated with the phosphor, okay, and then wherever it will hit, so there it will glow. So, we will see the spot. Now, that spot can be moved along the x direction or along the y direction, applying the electric field in those directions. So, how we are applying electric field? So, we are applying electric field using the capacitor, using the metal plate, okay. So, and also you know this also if you use the magnetic field, then also you can this electron beam will deflect in electric field. So, that I think that also one can use. So, to deflect the electric charge, moving charge, one can use the electric field, one can use also magnetic field, okay. So, obviously in electric field it is there. So, because of that we get current, okay. In magnetic field also you know this due to the Lorentz force Q V cross B, because of that force. So, there will be because of that force on the electric charge. So, depending on this direction of the force, it will move towards that, okay. So, I think yes, I will demonstrate, I will show you this CRT tube and demonstrate this how we are getting the spot on the skin, okay, from the CRT. So, I will stop here and I will continue in next class. Thank you.